single lithospheric plate of Mars, which leads to Marsquakes. But does geological activity on Mars bring us closer to solving the mystery of its habitability? We know this planet as a very harsh and inhospitable world, extremely cold, with terrible radiation and no liquid water. And of course, there's nothing like elephants, tigers, or even mice on its surface. They wouldn't withstand such conditions, and we could easily notice some of them with telescopes or rovers. But we wouldn't notice microorganisms with these tools. Microorganisms are able to survive in extreme conditions on Earth, so there's a possibility they could also exist on Mars, especially in its depths, where it's warmer and there's no fatal radiation. Additionally, the discovery of subsurface lakes on Mars is an exciting finding, as it suggests the possibility of liquid water, which is an important ingredient for life as we know it. In 2018, radar instruments on the Mars Express spacecraft orbiting Mars detected a large underground lake on the planet's southern pole, as well as 3 smaller bodies of water nearby. The lakes span an area of over 75,000 square kilometers. This region is located in the Planum Australe, a large ice-covered plain. And in 2022, instruments on the ExoMars orbiter showed there are also giant reserves of frozen or liquid water in the Valles Marineris canyons. They're hidden inside a canyon system running along the equator of the planet. The water in the canyons covers an area the size of the Netherlands. It's located very close to the surface of the planet, within the top 3 feet of soil. On Earth, similar subglacial lakes in Antarctica have been found to contain microbes, fish, and other organisms. This could also be the case on Mars. A small amount of heat is retained beneath the surface of Mars from the planet's interior, but it may not be enough to melt the ice. This means that lakes may be frozen due to a high concentration of salt. If it's 20 or more times saltier than Earth's oceans, even microorganisms would not survive. In order to understand this, scientists are trying to determine the composition of water in the underground lakes. They're also searching for signs of life in dried-up surface water bodies. Once, many lakes and rivers flowed on Mars. The planet was warmer and had an atmosphere. Many different organisms could have lived in such bodies of water, but up until recently, we couldn't find any traces. In September 2022, the Perseverance rover made a shocking discovery. It found organic molecules near ancient water sources. This wasn't the first time that rovers have found organic matter on the red planet, but this discovery is important because it was made in a place of ancient river-lake merger, particularly favorable for life. It's located in the Jezero crater, 45 kilometers in diameter. The delta formed about 3.5 billion years ago and had been accumulating sand, dirt, and salts over time. Perseverance has extracted the largest amount of Martian organic molecules from this mixture to date. On Earth, fossils of ancient organisms are also commonly found in such sedimentary rocks. The Sherlock instrument on the Mars rover Perseverance, which is designed to identify organic and chemical substances, scanned molecules from the Jezero crater. Among other elements, it detected hydrogen atoms linked to carbon atoms. Carbon is crucial for life and may indicate biological activity. It's also important to note that the organic molecules in the Jezero crater sediment are intertwined with sulfates. On Earth, sulfate deposits preserve organic matter and often contain signs of life. However, the molecules in the crater may have formed through natural processes. Scientists will be able to determine their origin more accurately once samples are brought back to Earth, which NASA plans to do in future missions. Meanwhile, scientists have discovered other hints pointing to the possibility of life on Mars. Recently, the Curiosity rover detected an unusually high level of methane on the planet, 21 parts per billion units of volume. So what does this tell us? Methane in higher concentrations is found in the Earth's atmosphere and is formed due to the emissions of living organisms. Researchers are planning to find out if the gas on Mars is also related to the activity of its inhabitants. If the methane had formed a long time ago, it would have already broken down into its component elements. Another possibility may be that the gas is a product of interaction between rock and water. But methane isn't the only gas scientists are curious about. Carbon dioxide, considered harmful on Earth, may soon become invaluable on the red planet. The experimental device MOXIE, the size of a toaster, was brought to Mars on board of Perseverance. Its parts were printed on a 3D printer from a nickel-based heat-resistant alloy. Its composition also includes a lightweight aerogel for heat retention and a thin external gold coating that reflects infrared radiation. Thanks to this, the unique device is able to withstand a temperature of 800 degrees Celsius, at which gas transformation occurs. MOXIE has recently produced pure oxygen from CO2. It works by separating oxygen atoms from the CO2 molecules. The byproduct, carbon monoxide, is released into the atmosphere. The tool is designed to produce up to 10 grams of oxygen per hour. However, after an hour of operation during the first test, the gas output was about 5.4 grams, enough to let an astronaut breathe for about 10 minutes. The device is particularly valuable because it's virtually unlimited in terms of raw materials, as the atmosphere of the red planet is 96% carbon dioxide. Also, MOXIE uses regolith, which covers the entire Mars. After processing, this soil becomes fuel, air to breathe, or, combined with hydrogen, water.